This is number 14. The greatest common factor of n in 540 is 36. Which of the following could be the prime factorization of n? And then we have our answer choices. one of the things we should have done in the very beginning is we should have used, our right brain and sort of glanced at this problem and looked at the big picture concepts here. I think that's always good. And really, big right brain capturing the big picture is sort of notices some things that pop up right away. So right away when I look at this, especially when I look at the answer choices, I see that all the answer choices are written in prime factorization form. This is a representation of numbers in terms of their prime factors. So A says 2 to the first times 3 to the second. That's like saying 2 times 3 times 3. So A actually represents 18 numbers. When you write a number in prime factorization form, you always want to lead with the smallest prime number. So let's look at D for a moment. It's leading with the 2, then the 3, then the 5. Fair enough. All right, always remember that. And then even though some of these values like this 2 times 3 to the second, even though there's no 1, I want you to think of it as an implied one. So really it should read 2 to the first times 3 to the second. Or number C could read 2 to the fourth times 3 to the second times 7 to the first. Alright, I'm just being picky there. But anyways, first thing I notice is going to involve prime factorization. I also see prime factorization in the problem itself. And then it has something about greatest common factor. Now, greatest common factor, this involves, first of all, finding out the factors. We have ways to find out factors in numbers. There's lots of different ways. We're going to use a strategy, we're going to use a Venn diagram strategy again as a way to do the prime factorization of these two numbers, use the greatest common factor detail, and help us answer the question. So let's start here. I have these two numbers, and I'm going to represent them in the Venn diagram. This is a little tricky at first. The first number is n. We don't know what n is. The second number is 540. And all we know is that the greatest common factor of both these is 36. Now, I don't know if we've done this. In other videos I have. This middle portion of the Venn diagram, this represents the greatest common factor. So both these numbers are divisible by 36. What does that mean? Well, if we were to do a nice one, like let's say 12 and 15, 12 and let's say 12 and 6, and we write out the factors of 12, 1 and 12, 2 and 6, 3 and 4, and 6 would be 1 and 6, 2 and 3, and that'd be it. Well, the largest factor that the 12 and 6 share, this is a number that they can both be divided into evenly without any remainders, is 6. So we would say the largest factor of 12 and 6 is 6. Now, how is that represented on the Venn diagram? Well, 12, remember 12 can be represented as 2 times 2 times 3. And 6 can be represented as 2 times 3. The factors that they share in common are the 2 times the 3, and the 12 has the extra 2. So if you think about it, the 2 and 3 are the factors of the 6, and the 2 and 3 are the factors of the 12, and what's in the middle, 2 times 3 is 6. That's your greatest common factor. Well, the greatest common factor of n 540 is 36. Or in this case, it's going to be 2 squared times 3 squared, because that gets us 36. Okay, so let's take apart 540 for a moment, do the prime factorization of it, and find out what it's made up of. I can do that by breaking it into 54 and 10. Whenever you see a 0, if it's 1 0, pull out a 10. If it's 2 zeros, pull out 2 10s. And then I break that apart looking for the prime factorization of this number. So let's see, that's a 2, a 3, 3, 3, 2, and a 5. So 540, it could be I could rewrite 540 as it's got 3 distinct prime numbers. 2, 3, and 5. It's 2 to the second, 3 to the 1, 2, 3 third, 5 to the second. Now we already have 2 to the second and 3 to the second accounted for, which means I'm missing a 3 and I'm missing, I'm sorry, just one 5 and a 5. Now let's solve the problem. When I do this, I'm going to play a game. It's got 2 rules. I got to ask myself these 2 questions about n. Does n have a minimum requirement? It has to have a minimum requirement of 2 to the second and 3 to the second. It has to have that. At least have 2 to the second or 3 to the second. It's like you, I make a joke about this. It's like you're going on a date with someone and they've got to at least have a job and they've got to at least be, be handsome or be very good looking. Whatever your criteria is, it's got to be 2 to the second and 3 to the second, or else you're not going to do it. Well, if we look at our answer choices and we look at that basic criteria, A here doesn't meet the basic criteria. I don't know what the problem is. There's a problem though. It doesn't have 2 to the second or 3 to the second. So how could it share it if it doesn't have it? So we can knock that out for that first criteria. Then we look for our second criteria. This is what I call the non-negotiables. N cannot have an extra 3 or an extra 5. This is non-negotiable. Because if it did have an extra, let's hypothetically say it did have an extra 3. What would that do? Well, if n had an extra 3, like B is suggesting, if it did, and this has an extra 3 and this has an extra 3, it would fall in the area of greatest a shared factor. And that would change the greatest common factor to another number. So that can't be, like 108. That's not going to happen. So it can't have, these are kind of like your non-negotiables. I'm going to make this joke, no smoking, and you got to be nice. You can't be a mean person. Alright? So if the person, sorry if I'm alienating a whole group of the population that smokes, but anyways, you can't do this and you can't do that. So I'm looking for numbers here that don't have extra 3s and don't have extra 5s. I can eliminate B for that very reason. It has an extra 3. And guess what? Looking at D right away, there's an extra 5. There's also an extra 3. Now why does C work? Well, C works, pretend that's not there, or we could erase it. Why does C work? Well, we got a 2 squared. We got a 2 to the 4th. So that means it's missing, it needs an extra 2 to the second. And it needs an extra 7. Well, that 2 to the second doesn't bother me because it doesn't end up in this category here, right? And the 7 isn't going to end up here. So that's okay. C is a number that shares 2 to the second and 3 to the second, and only 2 to the second, and only 3 to the second with 540. And that's why the answer is C. Okay, team, I hope you found this helpful. Be cool. Keep on sending your questions. Check out one of the Harvard Square MTEL Math workshops if you need a good review for this test. And have a great day, okay? There's lots of other stuff at gomath.com. You can check it out, sign up for tutoring if you need help, or send me an email if you have any questions. Thanks. Have a great day. Bye-bye.